So our first speaker today, I'm absolutely delighted, is Freya Garry, who's a scientist at the Met Office UK Climate Resilience team. So perfectly aligned with our topic today. And she looks at projections of future UK climate change to understand how climate change will affect various UK sectors, such as agriculture. She has also co-founded the Women in Climate Network at the University of Exeter, and also is part of or ambassador at the Met Office promoting outreach activities to encourage students to study science, technology, engineering and maths, known as STEM. So a great passion behind there as well. So with that, Freya, I hand over to you. Thank you.
Let's go on to the first slide. So I'm going to give a quick overview today of some of the basics of climate risk, but although you heard me talk about my work over the last couple of years, which has been UK focused, I'm going to talk more globally today and highlighting many of the different ways that we at the Met Office work on climate risk, together with lots of different partner universities, organisations, and of course one of our main remits, which is to provide government with information around climate change and risk. So you'll hopefully be familiar with this picture on the left, showing here the change in global temperatures since the start of Industrial Revolution, where we started burning large quantities of oil, coal and gas. And you can see since then that we've already experienced a 1.1 degrees Celsius rise. Each of the last 4 decades has been successively warmer than the decade before it, with the last decade the warmest on record. Overwhelming evidence shows that this warming is due to human activities, burning fossil fuels, and the way that we've changed our use of the land as well. And the Met Office, of course, has played a pivotal role in showing that this climate change is happening, along with the rest of the climate science community. And you've probably heard of the Met Office's role in weather forecasting, but there's a lot of work going on climate timescales as well. So whether it be seasonal to decadal forecasts or longer-term climate projections. So on the right here shows one of the more recent projections of how climate's going to change over the next few years. And different users will of course have different reasons why this information matters to them. So a farmer might be interested in what crops to grow this year, or what different varieties they could bring in over the next few years, as well as extending onto the sort of climate relevant timescales that we'll talk about for the rest of today. Or in my talk anyway, I should say. And of course, a big role of this climate information is providing the information that will help society transform itself into a resilient society that can hopefully work towards net zero, and also be more resilient in terms of the changes that climate change is having and will continue to have, and the adaptation that we need to see to be able to cope with that. So here we show some of the extreme events that have been happening around the world over the last few years. Just move slightly to the left. And at the Met Office, as well as others in the scientific community, do a lot of work in climate attribution now, and that's simply doing the science to show whether specific events are due to climate change. And we have really in the last few years been able to do this a lot more rapidly than before, which is very important. So in these events happening, now every few months we have events that we can say are due to climate change and are made tens to hundreds of times more likely due to climate change. Here we see the different changes in the climate change is bringing. So these hazards, which we see in the middle diagram, in the middle ring of the diagram here, such as rising sea levels, warming oceans, changes to the hydrological cycle, vegetation, changes to the ocean. These are the climate hazards that the scientific community has been spending a long time working on trying to quantify and understand better. But we know that these hazards then have lots of different impacts on society. So showing around in the outside ring, such as food insecurity, heat stress, damage to different environments. And this is the risk part of climate that we are so concerned with today. So when we think about this risk, how do we put it together from this climate hazard information that in climate science we are so experienced with? We then look at the exposure. So does a climate hazard affect you? Will it affect your assets? How many people will it affect? But also the vulnerability. So example, the thresholds at which a hazard may become really critical. So will it cause a piece of infrastructure to fail, for example? And crucially, understanding this exposure and vulnerability information requires working in close partnership with people from an actual sector, getting that local knowledge and understanding. So it really is important that both the climate science community is working together with the rest of society to understand climate risk now, but also how that climate risk is projected to change into the future. Globally, some of the main climate risks have been estimated here, with projections for different levels of global warming. So you can see the estimates for risk in a future 2-degree warmer world and a 4-degree warmer world, and the differences between them. So, for example, heat stress risk becoming over 3 times worse globally if you're looking at a 4-degree warmer world. So that is very important for us to think about when we're understanding the future that we are going to see. It makes a huge difference at what warming level we do end up with, as well as the pathway that we take to get there. This is actually the same information in this plot, but globally. So you can see the regional distribution of how people are affected by these climate hazards. The warming that we've seen globally is not evenly distributed, with some regions and seasons warming faster and some people being more affected than others. Climate change is disproportionately affecting the poorest and vulnerable people in the world, with rural, coastal and indigenous communities facing greater risks. Climate change is one of the most serious threats facing our world, and as mentioned in the introduction by Peter today, it's a risk multiplier. It's making all those other global challenges that we have to deal with more severe. It's also causing a cascading risk, where you'll have knock-on effects across different sectors of society. So one example might be electricity supply. Droughts cause problems for cooling at substations, and then if you don't have electricity, buildings like hospitals have problems, anyone using a computer, and of course electric transport, which we might be so dependent on in the future. As well as these hazards here, as well as coastal flooding and other hazards, there's sort of these low likelihoods impacts that we're not necessarily expecting to see in the near future, but that might be very important if they do happen. So things like ice sheet collapse or dramatic changes to ocean currents. And we know from our earth science that these things do happen in Earth's history, so they are possible outcomes. So the study of these so-called tipping point impacts is also really important to include in risk assessment. And that's one of the things that we do continue to study at the Met Office as well. So there is still a chance of being able to limit warming to 1.5 degrees this century, but this will require rapid, sustained, and widespread reductions in the greenhouse gases that we're emitting. So to reach this sort of low emission pathway by immediately reducing greenhouse gas emissions, reaching net zero carbon dioxide emissions by 2050, and then having net negative carbon dioxide emissions afterwards, would still give us a 50% chance of reducing warming to below 1.5 degrees Celsius by the end of the century. But innovation that depends and builds on existing technologies to remove carbon dioxide from the atmosphere is required to do this, along with behavioural changes across society. So it's a big challenge. Many changes due to past and climate change are irreversible for centuries to millennia. So changes to the oceans and cryosphere can't simply be reversed. It's virtually certain that mean sea level rise will continue for the rest of the century. We're already committed to that. But reducing the emissions will reduce the impacts that we see. I'll finish here with a cartoon by the scribe's 3 blind mice at one of our Met Office, World Meteorological Organisation and IPCC sessions in the Science Pavilion last year at COP26. And I think this is a nice summary of what I've been talking about, the role of science in helping the world adapt to climate change. So we're providing that information, both about the diagnosis, but also the treatment of the climate change, as well as working together to develop tools to help society understand their climate risk now and in the future, and also the information to help society make decisions about how they adapt to this climate change. Thank you very much.